And hey, thank you so very much. I'm very excited to be here. Hello, everybody. My name is Jim Manico. I'm going to be your presenter today. Let's talk about DevOps or DevSecOps or whatever iteration of this topic you want to call it. Let's get into it. And before I get started, I want to say thank you to Jimmy Mesta. Everything I know about DevOps, I learned from Jimmy. So a lot of this presentation is from him. I appreciate his effort and works in the world of Kubernetes and DevOps. Thank you. Hey, please don't hack without legal written permission. I just like to say that. My name is Jim Manico again. I'm going to be your presenter today. I've been a developer for about 24 years. I've been doing application security for over a decade. I'm an author. I'm from Hawaii. Aloha to all of you. I'm real happy to be here. Look, these are some traditional DevOps slides. I've seen a lot of presenters put up the fancy DevOps unicorn and try to take you to the world of DevOps magic. Look at this slide. The psychology of this slide is interesting. They're promising you the world of DevOps, that when you're doing DevOps principles with security, everything is magic. And I think that's a really bad message, because this is not magic. This is not going to change your world. This is a discipline that will help you automate, for the most part, certain aspects of development to make security integration different and in some way more achievable and more frequent. There's also culture changes around how you develop code. So this slide, while it's fun, and I want you to have fun, it paints a bad message that there's some magic involved. And it's not magic. We're not magicians. We're engineers. This is a classic engineering principle of automation with some modern additional adjustments added to the modern development age. So it's not magic, it's engineering. And that's where we're going today. So what's the situation? There's a lot of false messages about what DevOps is, and there's a lot of critiques about what it is. There's a lot of extreme commentary about how it's going to solve all your application security problems on one hand, and on the other hand, people are calling it BS. Forgive the swear word on this slide. But so I think for me, the heart of DevOps, where the ideals of DevOps really meet the hype. And let me try that again. Where the concepts of DevOps get beyond the hype and take us to reality is really when you get into the concepts around continuous delivery and the automation around that. Trunk-based development, test automation, getting security done early, primarily in an automated way, and being able to deliver in a very rapid pace. In the world of Agile, we have sprints where we tend to release on a cyclic basis every week or every couple of weeks. But in the world of DevOps, when it's taken to its ultimate fruition of technology capability, we're suddenly deploying code with elaborate security checks built in to the actual deployment process. We're deploying hundreds, if not more times a day. So that's a promise. Go to your boss and say, hey, how often do we push code? Once a month? That's interesting. We push code once a week. Hey, boss, this new DevOps stuff, hey, I can build security in and start pushing code live hundreds of times a day. That's compelling. But what is it really? Let's go back to the beginning. So what really is DevOps? I want to look at DevOps from a anti-pattern point of view, from a high-level philosophical point of view, to start the conversation. Because even though there's a technology engineering undercore to DevOps, there is a cultural change that's going to happen, and that's reality. Now, I often look at development culture, and I don't like the term, but I'm getting to like it more and more, because how you write code, a lot of the subtle ways that you build your teams and interact between teams, these are $1 million decisions. This culture is really, and the reason why I like the word culture is because it's really subtle engineering processes is what we're talking about and critiquing. Anyways, we're not here to fire the ops team. We're not just going to hire a new DevOps unit or buy a DevOps unit. There's something more at play here. And the idea is not that we just write whatever code we want and throw it over the wall in operations to deploy it. This is the pattern of traditional development teams from back in like the 90s and 2000 era, in the early stages of web development. Very often your dev and your server teams or your deployment teams are very different teams with different skill sets. This is really the main thing we're trying to get away from as we approach the DevOps world. And so the other piece of this is we really don't want a separate DevOps team as a whole separate unit. The point is not to add more, more process and another team and more overhead. The idea is to make these silos go away, not build a third one. So when you have a separate DevOps team that's not really working with the other teams, but is kind of working in isolation, let me give you a little quick story. On several occasions, I've seen this DevOps silo work independently, roll out an automation pipeline, and then tell development they have to go through that pipeline, and without kind of integrating or discussing or working with development. And this really shuts development down. You have to be, at the very least, and this is an anti-pattern, but this is at least close, where DevOps is integrated into development. The automation part of development is built within the development team. That's great, but we can't just throw that over the fence to operations. And just like we can't just develop in isolation and have the operation team forcing automation on us, that's not going to work either. You need developers say on a day-to-day basis around different parts of development automation to ensure it fits the current engineering processes of the team and other expectations the team has by management. Again, ops will handle it is what we're trying to get away from. And this common problem of, it worked fine in dev, and I threw it over to the server team or to ops, and it's not working. Not my problem. It worked fine on my laptop. This is an example of siloed teams that don't have proper integration. And so now we're getting close. The idea is I still may have a dev team and an operations team, but operations is intimately involved in my development processes, and development is prepping for operational delivery as part of early stages of development. Oh, now we're getting better. So this is honestly, this is what I'm looking to pull off. Rarely are my teams fully integrated. There's still usually two teams, but they're tightly integrated, working together, sharing members on each team, building automation and similar together. This is usually where I want to be. Now, the ideal, the Platonic form of DevOps is kind of like this, right? Where there's one big team, everyone has shared responsibilities, everyone is essentially a developer writing automation scripts, writing operation scripts, and everyone's on the same team from building to deployment to monitoring. That's the ideal. Frankly, I rarely see this because we do have specialists within our teams that get a little bit siloed. So I'm looking for this from a reality point of view. But if you have some special DevOps, if you have some special DevOps unicorn magic, maybe you do this. I'm not looking for magic. I'm looking for reality and like acceptable engineering. So that's my world, but I digress. Let's go a little deeper into DevOps. Go a little deeper. What is DevOps? People, process, tools, and some buzzwords. This is the common three silos that we're trying to avoid silos. Let's try a different word. These are the different like categories of delivery that we're going to do within the DevOps world. People need to be trained to write code differently and to check in code differently and to treat security differently, right? We're going to be working on code, for example, and rather than doing one ginormous check-in of thousands of lines of change code, which is harder to analyze from an automation security point of view, a DevOps culture is often checking in much more frequently smaller bits of production quality code that can be absorbed by security automation a lot better. So regardless of what your processes are, the way people interact on a dev team is going to be very different in a mature DevOps shop. And the tools that you're going to use, you're going to have a whole different kind of development automation. You're going to have different kind of integration with security testing tools, the static analysis, dynamic analysis, the different third-party library scanning tools. You'll have a different relationship with those, a much more daily relationship with those tools. And again, the processes of how we're writing code changes pretty dramatically as well. And so here's the things that change in the process point of view, right? We have lots of cross-training. We have lots of cross-training in that, again, we're trying to have a good union of developers and operations, all with shared responsibilities doing automation and testing work. And we want regular daily communication. Like when I'm doing a logging standard, I'm not just making a guess as a developer. I have an operational focused professional and a development focused professional working together to come up with a logging standard. So all parts of the DevOps team are happy, are getting the goals they need from a security point of view. We also want to support business agility. And the way I translate that is, again, a mature DevOps shop is going to be pushing code many, many times a day. The ability to fix fast, build fast, fail fast, but correct that fast is the heart of DevOps culture, right? And everything becomes code in the DevOps world. It's an automated environment to do. Really, I don't think you can do DevOps without the automation. And so everything becomes code. Your different build scripts, your deployment scripts, your security testing scripts, these become not some secondary little toys that operation is working on. These become integrated part of how we're writing code now. And I think that's a big differentiation of an operational team versus a DevOps operational team. When I'm doing operations, I know a lot of folks automate their tasks, but there's a bunch of scripts lying around. When we get closer to a mature DevOps team, these are developer reviewed and maintained scripts that are integrated into our build and deployment environment and more. So because these operational toys become fundamental parts of how we're building and writing code and more. And our testing, our measuring, and our monitoring, again, that's not pushed off to a separate team. That's integrated part of development with lots of operational support on a day in and day out basis. So DevOps is about automate the building, automate the testing, automate the deploying, automate the monitoring, and we want to build this automated pipeline slowly. One of my big anti-patterns is when a separate siloed team builds a pipeline and forces developers to use it without really working with the developers to customize it. So really, you want to start pushing out different kinds of, when you're first rolling out a DevOps environment for a certain developer team, we want to roll this out little by little. We want to roll and be willing to change a configuration, roll back a certain kind of testing, configure the tool differently on a day in and day out basis until it's really working for that particular team. Another big anti-pattern is, let's build one pipeline for the entire company of lots of different developer groups. We often really need to customize our DevOps automation pipeline separately for different dev teams and different technologies and different sub-engineering cultures, sub-processes that different teams. So that's the ideal, right? The ideal is that we have DevOps professionals, operation, developer, all mixed together, tuning that automation specific for each team. And now that really helps lead us to success much more quickly. What else do we have? Let's talk about some of the practices here. So traditional SDLC, we're doing more linear progression of development. We're passing the code from one step to another, trying to get away from this very slow, methodical way of writing software, and instead have a more rapid approach with the aid of advanced automation. We're able to really crank out code fast in a very specific methodology that lets us walk through all this automation every time we try to do certain key things in development. So like when I'm trying to build a certain application, I've made some code changes, I did some unit testing, and I'm going to build the app. During that build process, we're just compiling code and preparing it to deploy it on a dev server or my local server. A suite of automated tests run, and these could be a combination of my personal unit tests plus a variety of different security testing tools. And this is a really important part of where DevOps and security really meet. This is about, how do I do this automated testing in the DevOps world? So there are three major tools, right? There's static analysis. This is a code scanning security tool category. There's dynamic analysis. These are like application scanners simulating pen test activity. Then there are third-party library scanners, right? And these are looking for third-party components that are out of date. When I normally run these tools as a professional, the scan time for these tools might be, especially for static analysis, it might be a couple hours or more. Same thing for dynamic analysis. It might be a couple hours or more. How do I move fast when the tool takes hours to run? Well, I can't. I'm not, every time I build, I have to wait a couple hours. That's not going to work. So the first thing we want to do in building a DevOps pipeline, a pipeline that's going to catch developers' security problems as they do their work, that we want to really tune these expensive tools to run furiously fast, have a really elaborate cloud or heavy duty server environment with lots of horsepower, be able to crank on these tools as fast as we can so we give developers feedback as immediately as possible. Now, let's take one of these tools and let's look at static analysis. Again, we're looking at the automated test suite here, part of DevOps. This is really where security and DevOps meet. How do you integrate security testing in a DevOps world? And again, I want scans to run fast, and static analysis typically takes a very long time to run. So one of the critical parts of DevOps pipeline delivery is to tune your security tools to run fast. So when I buy a static analysis tool, they're typically extraordinarily expensive. These are not cheap tools. Why would I buy an expensive tool and configure it by removing the majority of rules, disabling the majority of rules, or maybe even not even scanning parts of my code base to only hit targeted parts of the code base so it runs a reduced rule set and runs fast? Why would I want to do that? Well, the whole point is I want to give developers immediate feedback. So this is the main DevOps first phase, tool tuning. Get me some security testing tools, static analysis, dynamic analysis, and third-party scanning, and configure them to run fast. But why would you buy an expensive tool and basically neuter it? Well, I think the answer is we want to run our commercial or whatever our security testing tools are in two different modes. When the developer is working and trying to commit code or build code, then I want a test suite to run that focuses on running fast. And then an out-of-band DevOps process would run perhaps once a day in the evening after my main developer core is done working for the day, or near the end of the day or the beginning of the day. Then I'll run a full scan that takes a couple hours or longer and have that reviewed by a security professional. See, now we're leveraging tools, the automation part, for what they're best at. We tune in terms of integrating with developers' daily behavior. We reduce the time. We put them on as much infrastructure as we can afford in terms of horsepower to run these tools, so they run frequently, fast, every day, every build, every commit. So it's part of how developers do their job every day. And then, so we're not wasting the power of these expensive security tools, we run them off band or out of band once a day in full scanning mode. So we pick up all the other rules that require an expert to triage typically. And now we're cooking with gas here. Now we're leveraging automation for what it's best at, but still leveraging the tools out of band for what they're best at in full scanning mode. So what else do we have here? A few more notes here. Continuous integration. Again, this is the key part of continuous integration. Automated checks are fired off every time a commit is made. And I've seen different teams block these checks at different phases. Some choose to do the blocks at build time in the developer's local dev environment or cloud dev environment. Some will do these tests at check-in time. Some will wait to a production pullout. And I, at the very least, I really like the idea of check-in hooks that force developers to go through at least a minimum amount of static analysis or other security testing tools. Let me jump ahead here. You know, in production, the key thing I'm looking for is preparation for deployment integrated with the dev team. And so I should be able to deploy in an automated fashion with zero downtime. And this requires sophisticated deployment capability. And as we shift to cloud type development, I think this is getting a lot easier and more turnkey. But especially for more legacy systems, this is really difficult to retrofit an older build environment where you're running your own scripts, you're doing things by hand. And now as we push that to a more DevOps model where we want to automate that, that's really heavy lifting, requires modern tool sets to pull off. But luckily, they're there for us. The last bit I want to talk about is how communication changes. I mean, for example, I really want to limit developers from touching authentication code unless unless they have a good reason to do so. Building authentication systems is mammothly complicated. There's huge number of new requirements like credential stuffing and all the NIST 863 different password controls. So building an authentication system is very complicated. I do not want my developers touching it unless it's for a good reason. So I may, number one, restrict who can even look at that code base. And number two, every time someone checks it in, I'm going to make an alert on Slack in my my communication channel. So there's notification on the common developer authentication group of people. There's notification every time that code base changes, and that's going to keep alerting until someone reviews it. So I make a change to authentication, they pass all the unit and security tests, that gets pushed live right away, and Slack gets notified. Someone just pushed authentication code live. Until a senior member of that team goes in, reviews that change, already live, but they review that change and approve it, Slack may keep complaining that there's a review, that there's an authentication change that's live that no one has reviewed yet. So this kind of like chat operation, there's an infinite number of ways to configure this. That's one way I've seen it, that kind of automated communication and collaboration integrated with different code check-in tools and similar. I think that's very powerful. And it takes work. It takes development time to build these integrations, but it's extremely powerful to help communicate major changes and still let folks run fast in the DevOps way. You know, everybody wants to turn things into this. This is not about magic. This is not about impossible to achieve goals. It's more like it's really more. It's closer to this. You know, we're gonna do some shoveling. It's hard work. The hard work is rewarded with just more hard work. It's an evolution. You're constantly fine-tuning and changing things. So I like this diagram better. It is hard work. We're shoveling and we're cleaning and we're fixing and we're tuning. And that's more fun. This is not my fun. This is not reality, folks. It's okay to be shoveling. That's the symbol of getting the work done, right? And so we have these competing forces between the desire to get it done fast, the desire to build it in a robust security way, and the desire to keep things up. But the great thing is the mature automation that's available. These techniques that have emerged, the tools that show up in the DevOps world, I think they really let you combine these competing forces and put them all on the same table together. When you've come out the other end and you have now a mature DevOps pipeline where your developers, operations, security are really integrated on the same team and have a lot of shared duties between them. When every time I check in a piece of code, there's an elaborate number of security tests running very quickly before I check it in that's integrated with my chat operation so people are reviewing what I'm doing in real time. And if I make a security mistake that's caught in the initial check-in, I'm blocked, or maybe the later scan once a day may catch it, which will alert the team, or maybe someone in chat operations sees an authentication check-in and they review it and they see a debug in it. And now we have this engine running. Suddenly you get good security, the ability to fix fast and automated security testing. Operations is happy because development takes responsibility for operations, and development is happy. I can rock fast. I can do this cheaper. I can make changes super rapidly now, and it forces a kind of discipline onto my team. So this is why I like DevOps, because it takes all these competing forces and it brings it all together into one unified way of developing. And then, yeah, back to the unicorn slide where it's a journey. The journey is you don't just roll out DevOps and you're done. The journey is you have to, number one, be willing to tweak and modify and adjust your DevOps automation on a daily basis. You must be willing as a team of people to change how you write code and to abide by the automated guides before you. And your operation team must become a little bit more like developers to be effective. Developers need to talk to operations, and all this comes together. you are able to run and fly in terms of getting code out the door with safety, stability, all accounted for. And I think it's the reason why I sometimes rebel against the unicorn idea is because this is not special magic anymore. This is just the basics of what you do in development as part of engineering these days. Thank you, Jimmy, for what you taught me about DevOps. Hope you're well, Jimmy. And this has been a pleasure talking to you today. My name is Jim Manico. If you have questions for me beyond this webinar, I'm jim@manico.com. I'm very grateful to Secure Code Warrior for their sponsorship. And have a great day, everyone. And thank you so much for your time.